Okay, here we go. Number 4 is where we'll start. Okay, so first big idea. Make sure you keep track of the difference between absolute max versus relative max. They're related but not the same, so don't get them mixed up. Absolute max versus relative max. This problem says we're supposed to find the absolute max, but what you want to write down and memorize is the following statement. Let me get ready here. So write down and memorize that, let's see, F has its max okay, sometimes they use the word absolute max, sometimes they use the word just maximum, sometimes they just say greatest, most, highest, fastest, coldest, whatever, okay, biggest. But if they're talking about relative, they'll have to use the word relative. So if it's absolute, they can use all kinds of different words. But if they're talking about a relative max, they will say specifically relative max or local max. So that's how you can distinguish between the two questions, is relative and local will say relative or local. Otherwise, just look for some sort of wording that indicates biggest, greatest, fastest, highest, tallest, whatever. Questions? Okay, so F has its max either at a relative max or at an end point. So if they define an interval that you're investigating, there's always the possibility that the maximum value of F will occur at the first x-coordinate in the interval or the last x-coordinate in the interval. Questions about anything? Okay, cool. So we know we could have the max at one of the two endpoints. So E could be the right answer, A could be the right answer. But we've also got to go looking to see if F has a relative max. So the sentence we want to write down and follow would be this one. F has a relative max when F prime changes positive to negative. We lost somebody on their phone. So F has a relative max when F prime changes positive to negative. Okay? We have no pictures to look at, so we're going to learn a new method today. We're going to learn what's called a sign chart. Sign meaning positive, negative, or zero. And we want to make a sign chart of F prime, because we need to determine when F prime changes from positive to negative. Questions about anything? Okay, cool. To make a sign chart of F prime, we must have an equation for F prime. So we'll just start going around the room now. So, Will, what would be the equation for F prime?
It'd be the derivative of the F equation.
Perfect. 2 points for that. So Preston, tell us what the derivative of F prime would be in this situation. Oh, I know now. So Xander, what would be the derivative of f prime for this problem? Sorry, the derivative of f, my bad.
dy or d of x to the third minus.
So Xander's correctly saying I got to go do d, d over dx of that thing. Point for Xander. What would it be, Aspen?
3x squared minus 6x.
There we go. 2 points for Aspen. Question? Okay, cool. We got our formula for f prime. Making a sign chart is always dramatically easier if we factor whatever we are charting. So we're going to chart f prime. So if we can put f prime in a factored form, the charting of f prime becomes dramatically easier. Wait. So my formula for f is here. And so unit 2 says if I want to find the derivative of that, I do the add subtract rule first, and then I use the shortcut to find the ddx of each of those. So the detail there would look like this. We have, okay, we got f of x. We got f of x equals x cubed minus 3x squared plus 12. And then I go d over dx of f must equal d over dx of this stuff. Using the chain rule we figured out last time, this will become f prime of x multiplied by dx over dx, which is 1. This uses the add subtract rule and then the shortcut rule. Anybody else? Cool. We need a factored version, so Ellie, can you tell me how to create a factored version of this?
Take 3x,
Go on, Ellie.
and then in parentheses, x minus 2.
2 points. Questions from anyone? Okay, the next thing I'm going to write on the paper, you all want to make sure you write this down because on the written section of the AP test, the item I'm about to write will often result in a full point for something very, very simple. So don't ever forget to write what I am about to write. They always give, not always, but very often will give a point for this. You write on your paper, f prime of x has a value of 0 when, we'll go to Nadia, x equals what, Nadia? What value of x will cause f prime to have a value of 0? So x equals 0 works because if I put a 0 here and a 0 here, I have basically, you can think of this as 2 factors. If there's a 0 here, Nadia, what will the first factor equal? Right, and now I don't even care what the second factor equals because 0 here multiplied by whatever here would give me a value of f prime equal to 0. 2 points for Nadia. So x equals 0. Let's go to Claire. Is there any other x, Claire, that when plugged into this f prime formula will give us an f prime value of 0? Because now, if I put a 2 in for both x's, this is 6, but I don't really care. This would be 0. 0 times whatever is still 0. 2 points for Claire. Questions? Cool. This literally, right here, nothing else, this often gets you a full point on the written section. Just remembering that you've got to figure out what f prime is equal to 0. Okay? Now we're going to do the sign chart. That's the new thing for today. It's not really very new. You've done this kind of thing for years. All that's new is we're just going to pay attention to the sign, and we don't really care about the numbers. So we're going to chart f prime compared to x. And where you always want to start the chart is with the zeros of whatever you are charting. Technically, this problem didn't apply, but in some problems we would have to worry about f prime equaling 0 or undefined.
Why did they want you to find that?
Say again.
Why did they want you to find where f prime equals 0?
Gotcha. 2 points for Preston. The reason I do that is when I start charting f prime, where I start is with these two x values. So I go in order, so 0 comes before 2. Leave a little space because we need some numbers in between. The idea is that because x equals 0 and x equals 2 are the only x coordinates where f prime actually equals 0, that means that for all of the x coordinates here, like every x coordinate that is less than 0, so all of the x coordinates that are less than 0, all of these all the way to like negative infinity, every one of those x coordinates will either be positive or negative, but they won't be both. Because this function f prime is continuous, which means f prime cannot change from being positive to negative unless f prime has a value of 0. So finding the zeros first allows me to do very little testing to figure out what's happening everywhere else. Not the best answer, but does that help a little?
Yeah.
Okay. Anybody else? Cool. So we'll go to Ian. All we have to do now is say, okay, if x is equal to, say, -1, or if x were equal to -2 or -3 forever, whatever we get for f prime is never going to change. So if we test for one of those x's, we're good for all the other x's. So Ian, if I put in a -1 for this x, the value of this first factor, will this first factor be positive or negative? So the first factor will be negative. And then we're going to multiply that negative by the second factor. The second factor here, Ian, will this be positive or negative? Also negative. So if x is equal to -1, the value of f prime is positive. And if x is equal to -2, the value of f prime is still positive. And forever, all the way to x equal -50. Points for Ian. Questions? Please.
So you can just check one of the x's because you're just checking for if it's positive or negative.
Yep, all we care about is the sign. We don't need to know the numbers, just need to know the signs. And like Preston said, once we've identified at what x does f prime equal 0, we don't really have to check very many other x's. 2 points for Lucas. Sweet. So Ella, we need another x to check. What other x does it appear we should be checking?
Just a positive one.
Positive one. We need an x that fits between this x and this x, because those are the x's where f prime had a value of 0. The most logical choice would be x equal 1. So come over here, Ella. If x equals 1, is this first factor of f prime positive or negative? Positive. Second factor?
Negative.
Negative. 2 2 points for Ella. Questions? Cool. So Kaylee, we need another one last x we should test. 3. It could be anything, actually. You could do 3, 5, 10, 100, whatever. Larger than 2, that's all we care. So I come back over here. First factor, Kaylee, would be, so positive. Number is all that we really care about. Actually, 3 times 2 would be 9, but. And then the second factor, also positive. 2 points for Kaylee. Questions? Okay, raise your hand and answer this question for me. Raise your hand, please. At what x does f have a relative max? Hands up, everybody. At what x does f have a relative max? Remember the statement right here. This is what's guiding our work. So at what x does f have a relative max? Let's go, Sam.
At 1.
So at x equal 1, f prime is already negative, so not there, but close. We're looking for the exact x where f prime stops being positive and switches and becomes negative. 2 points for Sam. Hands up. What is the exact x where f stops becoming positive and starts becoming negative? Let's go HT.
0.
At x equals 0, so for all of these x's, all the way to x equals 0, all the way from negative x equal negative infinity to x equals 0, the values of f prime are all positive. Then from x equals 0 to x equals 2, the values of f prime are negative, so the switch occurred right there. That's the other reason why we're focused on that, because that's where the switches will occur.
And draw the relative min at x equals 2.
Relative min at x equal 2. If you had that, put yourself down for 2 points. Questions? Please.
Well, how would you be able to know that? Oh, so it has to be 0. I just realized because all the other ones never change. Like with A and B, those like at the end point, at the intervals, they never change, right?
2 points for Aspen. F will not have a relative max at x equal 4 or x equal negative 2. You are correct.
Okay.
F only has a relative max at x equals 0. However, we're not looking for relative max. We're looking for where F has its absolute max.
But it's close to equal, so it's
Go see again, HT.
but it's on a close to equal, so it's pretty much relative. So
Oh, 2 points, but no. F could look like this. F could be a graph. I don't know what F looks like, but F could be a graph that looks like this. Comes down, has a relative max, and then comes back up. The highest point on F would be this last endpoint.
Oh, would it be 4 then? Because that's farther away, so it has more time to increase.
Oh, 2 points for that thought. However, not necessarily. It all depends on the formula for F. F could actually have some sort of appearance like this.
But it doesn't, because we know that they're always positive.
Oh, thank you. We do know that the values of F prime being positive mean F goes up, but you still could have this kind of occurrence. It may not have climbed enough to be the highest point on that interval.
Okay.
Does that make sense?
I'm trying to find out.
2 points. Let's go to Jay.
So is the absolute maximum value the same as relative max? Are they different?
Different.
So then it wouldn't be 0, would it? Because that's the relative max, not the absolute max.
I said that poorly, 2 points for Jake. The absolute max and the relative max can be the same spot, but they don't have to be. So the examples I just showed were what you were noticing was they would be different, but we could also have this situation. F could have this appearance. F could, let's see, come up, have a relative max, and then not get very high again. And so the max of F would occur right here. So that's why we wrote this on the board. 1 second, Nadia. F will have its max either at a relative max or at an endpoint. It can be any of the three.
So when you in that thing says f of x has its max, does that mean absolute max?
Absolute max. The key thing to watch for is if we are talking about any kind of max other than relative max, we are free to use all kinds of wording. But if we are talking about relative max, we have to use the word relative. Nadia, you had a question?
So for the relative max, it is only switching from positive to negative, and then like maybe that came off of that. So because you said it could either be the endpoints or the relative max, would you do it based on would you do it based on the derivative where it goes from positive to negative to get that solid answer, or would it still be 4?
It could still be 4 or -2. So we know that this graph has this graph of F has a relative max at x equal 0. That could be the highest point on F. Doesn't have to be. There could be a higher point at the very beginning spot, x equal -2. There could be a higher point at the very last spot, x equal 4. Let's go HT.
Is there anything stopping you from just plugging in all the answers and just testing them all?
So in reality, that's how we figure out where F is highest. We go find the value of F at its very first x coordinate. We go find the value of F at any x where F has a relative max. And we go find the value of F at x equal the last point on F. Whichever of these three is the greatest value, that's where F has its absolute max. Now, one caution. They wrote this problem in 1988, and I believe they gave the test and realized they had not done a good job of writing a good question. Because as HT said, they designed a question where you really don't have to do anything that we did. You could have just simply short-circuited the question and tested every answer and found the correct answer. So ever since 1988, I've never seen them ask the question this way. What they've changed to is they'll say, okay, that's too easy, we can't do that anymore. We'll just say, what is the maximum value? So these are all x coordinates, and they switch the question to now they'll ask you for what is the greatest y coordinate. So there is nothing you can plug in. You're forced to go through this process, which isn't that bad, to figure out what are your, they'll call these candidates. What are the possible values of F that could be the highest, and then you have to figure out which one is. So well done. Support. Please, Gabe.
So does the same thing apply for like relative minimum?
Exactly the same idea. Yeah. I typically will teach one or the other because the other is just the opposite. Support. Anybody else? Awesome. So last thing to do would be to go back to this formula, put in these three x values, and figure out whichever y value is greatest, that's going to be the highest point on F. Other questions? Please.
Are we ever going to run into a problem where there are more than just like 2 zeros, and so there might be more than just one relative?
For our class, the worst I've seen is 2 relative maxes. I've not seen them push you further because it's not really testing you any better. It's just giving you more work to do. Does that make sense? 2 more. Yeah. Okay, cool. Next one.